models from on the data set which is given here. This data set is basically based on R&D spend, administration, marketing, and from all these three features I have to detect what is the profit that is made. So I have to make different regression models. So let's start with the first one. Here is the first model, linear regression model. Here I have imported the three main libraries which I would be using. I have imported pandas as pd, numpy as np, matplotlib, and in matplot I have imported the pyplot part as plt. ds is my dataset basically, and I have written a code to import my dataset into the program. Here I have written the code to select the particular rows and columns which I want to for example, this x, I want to show that x are the independent features, and it is represented by all the rows and all the columns except the last column. This -1 here shows that I have excluded the last column from the data set, and this y is my dependent variable, and this column here shows again all the rows, and this -1 shows the last column. And so I have given the names to my dependent and independent variables. Now I would be training my dataset. I would be splitting the dataset into test and train, into testing and training set. So for that I would be importing the train test split from scikit-learn library, and from scikit-learn in scikit-learn library from model selection part I would be importing train test split. And this is the code I have written here to actually split my data set into training and test set. And I have chosen the size of testing data as 30%. This 0.3 here represent 30%. So I have splitted my data into training and test set. Now I would be training my data as per the linear regression equation. So for that I would be importing linear regression from scikit-learn.linear model, and I have given a variable rgr, which is my regression model. Basically I have just given a name to so I could just train my data. And here I have used the fit method, which would actually fit these x train and y train variables into this linear regression class that I have imported from scikit-learn. It would this rgr.fit program would fit these two variables into this class, and it would automatically apply an linear regression equation, and with the help of that equation I would be getting an output, and I am naming that output for now ypred, which is y prediction. So here I have written the code rgr.predict, which is to determine the output of my model that I have trained. And here this code would give the output of my model. And this code, the second line, is basically just for the precision, that is how many the digits I would like after the decimal. And I have put here 1, so you can see that there are only 1 digits after the decimal. So, and the other thing here is I have used the concatenate function to actually put these y predicted and y tested results together. So from here to at least here till this value are y prediction, that the results that our machine learning model has predicted, it is still here, and after that it is our test results, that is what our model has taken as input, what the model basically so from here till this number here are our y pred values, y prediction values, and from here to all these numbers afterwards is our y test values. So this is the code to write both of these values, both of these arrays together. So next I have found the coefficients, and coefficient that would be used in our equation. For example, if our equation is ax plus bx plus c, then so here I have found the values of the coefficient. For example, if our linear regression formula is ax plus ax plus bx plus c, then the values of a and b are these, and the value of the intercept, that is the c, is this value. The intercept value is this here, and it is the code that I have written to find the intercept value, that is rgr.intercept. And here I have just shown you that how could we just find any one value. For example, I have put the value of R&D spent, this is the value 10. I have, for example, just to test, I have put it here 10 R&D value spent, and this is the administration, 13 values for the administration, and the 7 values for the marketing. And based on these values, our model has given this output, that the profit would be this. So it was just basically a test of our linear regression model. Now this was the first model. Now second is our polynomial regression model. So here again I have imported the libraries, all the three, this dataset, and x and y I have defined them, splitted the data into training and test set. And now here I have not done what I have done in this linear regression model. Here, since it is a polynomial regression, I have imported polynomial features class from scikit-learn.preprocessing, and this is my variable, and I have written polynomial features, which is this class here, and in the parenthesis I have defined degree 2, since I just wanted to test it for a parabola, so I have written here 2, and if I wanted any other type of curve, I would have changed my number from 2 to 3 or 4 or any number, that doesn't matter much. So as long as it fits our data properly, it doesn't makes much of a difference. So this was our basically polynomial features class, and here I have just defined the export train, which is our. So here I have defined another function, export train, and here I called my function rgrpol, which I have defined here, and I have used fit transform method to change x train and x test into the according to the polynomial function, according to the to make them, to convert them in a proper polynomial function, and so that we could put the values here and here to get the proper answer. And now I would show you, if we don't convert these x train and x test into these export train and export test, then what would it show? I would like to show you here. It would show an error like here. It says x has 10 features, but linear regression is expecting 3 features as input. This is because we have not uh, not put it the proper value, which is x pole train here. Now if I just make it a bit correct, and here, and now it won't show any error. It is now properly giving the proper output and there is no error here. So here I have changed both these xtrain and xchest into these new functions, and now here I have imported the scikit-learn library. I have imported the linear regression from the scikit-learn library, from the scikit-learn linear model library. So now here we have imported the linear regression class again from our scikit-learn.linear model library, and here I have defined my function rgrlin is equals to this linear regression class, and now by using the fit method I have put this x pole train that I have defined here into this linear regression model, and in y-axis I have put it y train. And I also want to make clear that we have chosen pre-processing part of scikit-learn here, since we are pre-processing the value of our x variable and we are making it into into degrees of 2 or 3 or 4 and into a proper polynomial function. That is why here we have used the pre-processing part of the scikit-learn library, and here we have defined our linear regression model, and in this we have our polynomial variables, and this x pole train is our polynomial variable in this linear regression model. And here by the formula of y predict, this is basically the formula for prediction that our model would have made from all these codes that we have written here. And I have again put the same formula rgrlin dot predict, and here I have put it x pole test, which is this value, this polynomial value, which I have made from x test value, and this x test value I have converted into polynomial value, and this polynomial value I have put it here. So this we have defined our y prediction, and just to test that it is working, I have just to see the values of y predict, I have just written it here, and these are the values which are predicted by our model. So these are the values predicted by our model, and these were the test values which were the input from the dataset that we were given, and these were the dataset values, dataset profit values that we were given. And again, using the concatenate function, I have put both these values together, and till around this value, just give me a second, around this value is our test values, y test values. Till here is our y test value, and after this whole values are our prediction values, which we have predicted using our model that we have designed using these codes. Now we have done our polynomial regression, we have done our linear regression, and now one more model that I have created is random forest regression model. Again, I have imported these libraries. This is my dataset and x and y variables definition, and I have split it into training and test set. Again, here I have taken the test size as 20%, 0.2, and this from scikit-learn.ensemble scikit-learn library. We have an ensemble part, and from that part we have imported our random forest regressor, which is a class. And here we have defined our function rgr is equals to this random forest regressor class, and this n estimators, this is basically the number of trees that we want to choose into to represent in our model. For example, I have here chosen 25 trees which would be present in my model, and this is the normal random state. And here by using fit method, I have fitted my x train and y train values into this rgr function that I have defined here. And by using the formula of this random forest regressor class, we would probably get our values. And this random forest regressor class already contains a formula, and I have fitted my values that I was given in the dataset x train and y train into this regressor function, which is the function of this random forest regressor class. So now we would predict our results that we have got from this function that we have just defined. And this is the formula for the prediction, gr.predict x test, and this is our prediction values here. Y predict, this is the value of our prediction. Now the last but not the least thing is to check which of these models is the best model among the others. So to check this, we have a special kind of class which is r2 score, which we import from sklearn.metrics. This r2 score class would probably give a number like this, and the more close this number is to 1, the more perfect is our model. So this is my linear regression model, and the value of r square coefficient in this model is 0.957, as you can see here. For my polynomial function, it is 0.92, so which implies that my linear regression model is more better than my polynomial function model for degree 2, since the value is far more away from 1 than compared to this linear regression. And now my forest regression model, which gives almost the same value as that of my linear regression. Here it is 0.951 and here it is 0.957. So from this data we can conclude that the linear regression model is the best model for the dataset given. Thank you very much.